Hello guys, let's try to solve some problems in line with our topic meters and instruments. Again, welcome to this channel where we see to it that your needs are met. It says here, a swamping resistor of 150 ohms connected in series with a 1 milliampere 50 ohm galvanometer, and the shunt resistor is then connected across this combination to convert it into an ammeter with a maximum range of 3 ampere. And we are tasked to determine the value of the shunt resistor. First, let's understand some terminologies. For example, the swamping resistor, it is being connected into the circuit for the control of the temperature. That's called swamping resistor. And the other terminology here is the shunt. Shunt is another term for parallel. So when you say shunt resistor, it is a parallel resistor connected to the branch. So let's try to understand this problem by illustration. We will draw what is being stated there. So we are tasked to get the value of the shunt resistor. So here we have, for our given, we have here the galvanometer. So we write symbol for that, G, circle, and inside that is G. It means that it is a galvanometer. So this galvanometer is rated as 1 milliampere and 50 ohms. So it means that is the capacity of your galvanometer. Now, swamping resistor is in series with this galvanometer. So we draw a resistor here. This is equivalent to 150 ohms. So that's it. According to the problem, be able to use this circuit as an ammeter. So we know what is an ammeter is. Okay, an ammeter is a device that we use to measure the current of our circuit. How do you connect an ammeter? If you have a circuit and you want to get the current in that branch, you have to cut directly from that branch and connect your device. Okay, if you are using an ammeter, so it means that the current will directly go or flow through the device. Okay, so that's why there is a resistor that should be connected in shunt or in parallel. This combination. So let's draw. Okay, so it is like this one. So this is your shunt. Let us name this as RSH, the shunt resistor. Now this device will be allowed only to accept 3 amperes. It means that will be the maximum range. So the current here will be 3 amperes. So 3 amperes here means that this is the maximum capacity of this circuit or the ammeter. It means that less than 3 or equal to 3 is accepted. Current can be accepted only. So if it happens that the current is greater than 3 amperes, this system will blow. That's it. Now, our task to solve for this one. So you will notice that this is already a circuit. Okay, so how are you going to be able to solve for this? Simply, we just get the current here. So at this point, current at this, let us name it as I shunt. And the current here at this branch, which is given by this galvanometer rating, 1 milliampere. Okay, will converge here and will produce 3 ampere. So you can set up an equation like this one. So 1 milliampere, which is 1 times 10 to the negative 3 ampere. Okay, that is now in ampere. I have just converted this to ampere as shunt, the current here, that will be equal to 3 amperes. So automatically, we can solve for the I shunt, which is 2.999 ampere. We are tasked to solve for the R shunt or the resistor in parallel. So to be able to get that, the voltage in this branch is equal to the voltage here, that is in parallel. Therefore, if you are going to get the voltage of your galvanometer plus the voltage of 150 ohms, it will be equal to the voltage of the resistor parallel to that. Okay? So you can set up an equation. It will give you like this one. So 50, that is 50 ohms, that is the resistor of the galvanometer, times the current, which is 1 times 10 to the negative 3, that is 1 milliampere converted to ampere, plus what will be the current here? It is the same as this one. It is in series with the galvanometer. So again, 150 ohms times 1 times 10 to the negative 3. That is equal to the voltage here, ISH times RSH. But we have already solved for the I shunt or the current here. That is equivalent to 2.99. So we just write it 99 times R shunt. What do you observe in this equation? We have already an unknown here, which is R shunt. So by using your calculator, you just simplify, multiply this one, multiply, then you add. After doing that, you divide it by 2.99. Now in doing so, you get result of 0.06669 ohm. Okay, this will be the value for your R shunt, and this is what we are looking for, the shunt resistor. Okay, so thank you so much, and watch again for another video that can help you.